Okay, so what I'm going to do is I'm going to show you guys how to get a nice nest like this quickly and automatically through PEP and generate a quote. Okay, what I wanted to review with you is how we can make some fast and accurate quotes through going through the CAD converter and converting the parts accurately and quickly to nesting and getting a quote quickly. So what we'll do is I'll go ahead and open up CAD converter, and I'm going to convert about 50 files all at once. So I'm going to mark them all. I'm going to say auto convert, fully automatic, but pause for secondary operations if there's any in the drawings. This is just going to show me a list of keywords that are going to get found, and if it finds any of these, it's going to stop and let me know. We're going to convert them to a drawing, and I'm going to say these are all 1/4 inch. So it's going to go ahead and convert all those drawings that we had marked. And during this process, it's going to do all the things that maybe Bob has gone over already or that I've gone over already, where it's going to look for drawing errors and correct them automatically. It's going to ensure that there are no problems with the part through doing that, and verify dimensions if it finds any. You may also see some of these parts, there's some numbers and letters that are blinking by as it's going through this process very quickly. Those are a part number that the customer had placed on these drawings, and I have told it to automatically ignore that, but there are situations where you may want to scribe that or even cut things like that. So we can drive that to a scribe layer, but if you're seeing that, that's what's happening. That's all part of the INI, which is the set of automation that happens when we convert drawings. So that's it. We converted 52 drawings in 56 seconds.
Wow.
So what we're going to do now is we're just going to go and we're going to nest those parts. Now, this is the bullet nesting capabilities of it. I've got a spreadsheet from the customer, an Excel document, that tells me all kinds of information for these parts. So what I'm going to do is I'm just going to copy the part numbers and the quantities, and I'm going to paste them right into PEP, just like that. And we're going to hit F1, and I'm going to tell it we're going to make a quote for those parts. This is just telling me they're all just laser cut. There are no secondary operations. And here, because this is such a large nest that we're going to make, I'm just going to tell it to only nest 3 sheets of this nest. And I'm going to hit F1, and we're going to let it work its magic. So what it's going to do is it's going to go through all those parts that we automatically converted. We know we have a clean cutter path for them, and it's going to categorize them, and then it's going to start nesting them on the sheet in the best possible way. Now you're going to see it put the sheet down, and it's going to park down parts, and it's usually going in a rectangular area and then trying the best to fill the parts in a way that's going to make the most sense. So it's doing a lot of nesting in the background to figure out the absolute best way to get those parts parked on the sheet. And you can see, depending on what the part gets categorized as, it uses a little bit different way to nest it. It's always going to use the best way to nest that particular part. And you can also see the large purple parts here have been nested for automatic common line cutting. So there are some defaults inside of the software. You will get some when you start, but you can tweak them if you'd like. And what that's going to do is it's going to tell the software when you would automatically like to have these parts nested for common line cutting. So that means that you won't have to take the time to common line cut these yourself, as with some other softwares can be the case, and it's quite troublesome to do. But not only that, you're going to get the nesting utilization for it as well. So it's going to know your common line cutting, and it's going to nest around that. You won't have to change the nest manually. So here we've got sheet 2, and it's doing that same thing. It's filling the sheet up, and you can see these dark gray parts also fell within that common line preset defaults for what you would automatically common line cut. So the gray parts are a little different because right now there's a preset limit right now in those defaults of how many to put in a row before we use a fire break. And that fire break is that small little area of metal you can see. If I zoomed in, you'd see it a little bit better, but it's nesting, so I won't. That's going to help with stability of the skeleton and with heat management, so that you're not going to have you'll have some meat in the skeleton, so it won't wobble around when you try to remove it. And speaking of the skeleton, that's another thing that we also offer is skeleton slicing, but we'll go over that a little bit later. But that would just be cutting up the skeleton into easier to remove pieces for safety and also for some premium value on the scrap possibly. But there we go, sheet 2 is done. We're getting into sheet 3. You can tell it is also trying to go through these parts in a way that makes sense for unloading them. So the parts that were filled on here are completely different than the original first 2 sheets, but you'll notice that it's not using ones that it used before because it's already consumed them. It's always trying to put parts and fill them, and once it's done with them, you could unload those parts, put them on the pallet, etc. Oh, that's a good example back there of some more automatic common line cutting right there. And because of that, it looks like it got some extra parts up top that you wouldn't have got normally, which is a perfect example. Okay, so it's saying some parts can't be nested because of sheet quantity. That's because I told it to only nest 3 sheets. So once it's done all that nesting, it's going to do all the processing automatically. This is going to take all that time away from your programmer to be able to do this quickly and get accurate quotes out or accurate cutting. So it's going to do all the processing from adding lead-ins to tabs to sequencing, and always sequencing in a way that's going to keep the heat down and managed, and in a way that you're going to have less head raises, and we're going to speed the machine up too by doing dynamic lead-in assignment. So we'll talk about that a little bit later, hopefully, but all that stuff's happening automatically, and just like that, we have our quote being generated. So how fast was that to get a whole spreadsheet of parts into a quote that was maybe, what, 6 minutes? Maybe if I wasn't talking so much. But here we have a little preview window of those nests that we just made, of the sheets of the nest. Now this quote is indicative of what you would send to a customer. So it would not include this preview window when you print it, and it would not include this line at the bottom here that's telling you your markups for material and overhead, a drawing charge, an hourly rate, including the remnant cost, displaying the net weight 1, net 2, and the profits. So you can see this quote here. We customize it, just put your logo in there, which is often used by our customers. I didn't put a customer name into the nest, but had I put a customer name to a program by or any kind of comments or remarks, they would come out here. And we can have any of that information come out as a barcode too, if that's more useful for your shop. But then the quote's going to break down all the drawings, their name and revision. I didn't store any revisions. The material it's going to get made out of, the size of it, the net weight 1 of it, how many they need, the cost per part, and the total. And then at the very bottom of this, it's going to give us the total for the whole job. So the nice thing about this is how quickly we were able to generate an accurate quote, because as you know, hopefully, the faster you can get a quote back that's accurate, the higher the chance of getting that job. And the nice thing about PEP is you may not always have the same set of quoting rules that you're going to go by. You can always hit this recalculate button right here, and we can recalculate on the fly all the information that you just saw there. So this is going to be our feed rate, our timing information here at the top. But if we scroll down just a little bit to job costing, here's where we can control our machine usage per hour, how much we're costing for material per pound. Are we going to charge them for handling per plate and per part? Do you want to include the remnant in the cost per part? So are you going to charge them for any remnants that's left over when you make a nest? Are you charging a CAD drawing charge? That's more of an engineering charge. You may charge someone a certain amount of money per drawing if it's taking you a lot of time or energy. And then these are the markups that we talked about for material and overhead. And right now we're also costing for freight per pound. So if you know that you have a per pound weight that you want to include in the quote, you can capture that in here. So for instance, let's say that this customer, you really want to get this business, you might lower your machine usage per hour to 130, all right? Now what I'm going to do, you can see the numbers back there. Instead of hitting F1, if I hit F1, it's going to accept it and save it as a default. And I don't want to do that. I just want to do it for one time. So I'm going to hit F2 to accept all entries just for this report. And you'll see on the fly, it's going to recalculate all of that information in this report and give me a new quote that reflects that change. So the nice thing about that is you can always change that and then go back in and change it again if you don't like how it came out. But just like that, that's a very quick and easy way to quote accurately with PEP 2019.